Hi, and welcome to our lesson 2.2. Today it's all about the quadratic function. We're going to be talking about basically graphing quadratics. We want to begin with some of the properties of parabolas that you will remember. The parabola is a U-shaped function, or the graph of a parabola, U-shaped, and there is a lot of symmetry involved here. In fact, a vertical line right through the vertex, so there's a term for us, splits the parabola up into two pieces that are reflections of each other. This is called the axis of symmetry. And this parabola, since it opens upward, has a minimum value here, an absolute minimum. That is, it has a limit on how low the y values can go. This parabola opening downward still has the same features of the other, but instead of a minimum, of course, it has a maximum. The standard form for a quadratic function is this: f of x is equal to a times x minus h squared plus k. Now I want to tell you, or give you the key to this formula. We've got lots of variables going around in there. The a is a multiplier that either, as we've said before, widens or makes skinny the parabola. The vertex of a parabola in this format happens at the point h comma k. So if you remember correctly, this would mean we move you right h units and up k units, or that's the amount of shift left to right, up and down. The general form for a quadratic equation, at least that's what our book calls it, is ax squared plus bx plus c equals 0, or f of x equals whichever you want to say. I bring that up because the equation for that axis of symmetry is the line x equals, and this will be familiar, opposite of b over 2a. So the standard form helps us locate a vertex. If we're in general form, it's easy to find the axis of symmetry, and that's important because that's the x-coordinate of the vertex. So that's where we're going to start today. Let's move on. Wow, right off the bat we're throwing you a graphing problem. It says that we should graph this function, the opposite of quantity x minus 1 squared plus 4. And I would ask you to think about this. Do we know the transformations that have occurred to the parent function parabola? What's that minus do right there? What does this minus 1 do? What does this plus 4 do? Those are the questions that we have to answer, and I think that we know. This is going to be reflected over the x-axis. That's what the negative sign out front does. Reflect over x. That means that we're going to be opening downward. The vertex, well, see again, two ways of looking at it. The vertex, if this is h and this is k, the vertex is going to happen at the point 1, 4. Talking about transformations though, remember that 1 tells us that we're moving right 1, 4 out here added on, up 4. And so as you think about that, our vertex is moved to the right 1 and up 4. We know that we are opening downward. We've been reflected over the x-axis, so our parabola is going to have that kind of shape. And now, since there is no multiplier out here, we can apply what we know about parabolas. The next points that you can get are over 1 and down 1 in this case. Then if you go out 2 from the vertex and 4, so 2, 1, 2, 3, 4 right there, that point will be on the parabola. Back 2, down, and you can use that symmetry. There's our parabola right there. Opens downward, has vertex 1, 4, and we plot those points either by creating a table if you don't remember the pattern, or remembering that it's 1 and 1 and then 2 and 4. As you look at the next example, I'm going to ask you to think about these questions. First off, how is this going to open, up or downward? I hope you're thinking up. that's positive 2 out there. The vertex, this is in vertex form, is how I learned it. Our book calls it standard form. The vertex is at not positive 2, but negative 2. Remember, it goes the opposite way of what you expect. Negative 2, negative 1. Now this is different. See, this has the multiplier, so you can't just use that over 1, down 1 pattern here. The multiplier is going to change that. So this says find the x-intercepts by setting the function equal to 0 and solving for x. So I am going to ask you to do that. 0 equals 2 times x plus 2, quantity squared, minus 1. Solving for x, do the algebra. Actually, yeah, why don't we have you pause the video, do the algebra, and we'll catch up with you in a minute. Okay, I did solve that equation just by undoing things that have been done to the variable here. I came up with, and you can look at my work, but I came up with this, negative 2 plus or minus the square root of 1/2. Well, I stuck that in my calculator because I'm going to be graphing here, and the square root of 1/2 is about 0.7, so it's close to 1, but a little bit less. So the vertex is at negative 2, negative 1, and right now we know that the x-intercepts, so where it crosses the x-axis, are at negative 2 plus or minus 0.7. So maybe right in there and there. The last thing that we can do to get ourselves a fairly accurate graph is find the y-intercept. And y-intercepts happen when x is 0. So if you would do this, we want to solve y equals, and it's 2 times 0 plus 2 squared minus 1. We need to figure that out because that will give us the y-intercept if we make x 0. So we're 2, and this is going to be 2 in here. 2 squared is 4, times 2 is 8, 8 minus 1. That y-intercept is 7. So way up here, and then using some symmetry, let's see, that was 1, 2 over from the vertex. 1, 2, 1, 2. So way up here, and here's our parabola. And we graphed that by using what we know about standard form for or vertex form for the equation of a parabola, plus solving for x and y, and we can do that as well. All right, let's go on. If the quadratic isn't given in standard form, you still are able to graph it. And I'm going to just remind you right here that the x-coordinate of the vertex can be found by using this little ditty, which I hope we remember. X equals, and it's the opposite of b over 2a. So this is the standard form according to our textbook. If we're in standard form, we're going to look for that x-coordinate of the vertex by doing the opposite of b over 2a. Let's take a look at this one, see if we can graph this one. Opening up or down? Negative up front says we're going downward. The vertex will be, okay, here's where things get weird. The x part of the vertex will be at the opposite of 4 over twice a, and a is negative 1. So that's negative 4 over negative 2, or 2. The x part of the vertex is at 2. Folks, you have to find the y part of it. So you're going to use 2 in this quadratic equation, negative of 2 squared plus 4 times 2 plus 1. 2 squared is 4, the opposite of 4, so negative 4 plus 8 plus 1. That's looking like 5 to me. Our vertex is at 2, 5. And the y-intercept, that's one thing I like about this format. We know that it's 1. Crosses the y-axis at 1. So there's the intercept. The vertex is at 2, 5, so up here. We are opening downward, and it says that we can find the x-intercepts using the quadratic formula, and we can, but folks, I think that we can do a pretty good guesstimate of this graph just by using the symmetry. Again, we're 2 away from the vertex, so if we come here, we got to hit at 1 right there as well. Now, there's no reason why we couldn't find those x-intercepts, but if what we're looking for is a pretty accurate graph, we've got one right now. All right, I'm going to ask you to think just a tiny bit about maximums and minimums for quadratics. And it is easy to decide if it has a max or a min, because if it's opening upward, that is, if a is positive, then the parabola will have a minimum. It's going to have a bottom of the basket. And that minimum will occur at the opposite of b over 2a, that's the x-coordinate, and then the value of the function at that point. And that's just what we did a moment ago. If the parabola is opening downward, that is, we have a negative a, then there will be a max. And the vertex, again, can be found by going opposite of b over 2a to get the x-coordinate, and then finding the value of the function at that particular location. All right, we're to find the max or min of this function, and I'm going to ask you first of all, which will it be, a max or min? Yep, I believe that's a positive value for a, so we are going to have a minimum. I am going to ask you to stop the video, use this information to find where that minimum happens. So here's my work. I found the x-coordinate of the vertex by taking the opposite of b, positive 16, over twice a. So 16 over 8 is 2. Then I evaluate the function when x is 2. So I stuck a 2 in for x. I came up with 984. So the minimum value for this function is at 2, or the minimum occurs at 2. It is 984. Once again, let's make this clear. This is the location where the minimum occurs. The actual minimum for this function, the actual minimum is the 984. Okay? Occurs when x is 2, is 984. That's it for today. So we're going to ask you to get out there, try that you try. We'll talk about this in school.